This is called a Cartesian graph, and this is what we graph on most of the time. It has two axes. Why does it have two axes, by the way?
Because one is x and
The
one is y.
Y and the X.
Everybody stand up. Stand up. Stand up. All the girls stand on your desk. Literally stand on your desk.
Cheating.
Okay.
I can't get on that.
Okay, that's all right. Stand on the thing. Stand on about half of the rest of you stand on your chairs, and half of you stay on the ground. Yeah, Gannon's almost to the top of the ceiling, even on his chair. So, okay. Now, think about this being the x and y axis. So you stay right there. Stay right there. Think about right here. This is the x. This is the y axis, and this is the x axis right here, going across these. This should be up a little bit, but you see what I'm saying? This is the x axis. This is the y axis. The people who are on their desks and on their chairs, where are they?
One.
They're not even on the plane. They're not even on this flat area. Now, Danny's on the flat area. Why is Danny on the flat area? Because he's standing on the what? On the floor. Can you see that? You're on the flat area. You're on the x and y. Your x and y axis is correct because you're on the floor. You guys that are on your desk, you're not even on the Cartesian plane. You're not on the plane. You're on a whole different plane. What axis do you guys represent? The ones that are standing on their desk or their chair?
The one.
Z. The Z axis. Who said that? Who said Z axis? Logan said that? Nice job. Exactly right. There's actually 3 dimensions. Okay, you can go ahead and sit down. So think about this for a minute. Think about this for a minute. How do you view the world? How do you view things when you're looking, when your eyes are working? Do I see in 2 dimensions or 3 dimensions? Yeah. I mean, if I was standing right here and I only saw in 2 dimensions, I wouldn't see anybody but Callie. I wouldn't see Logan, and I wouldn't see Brian, and I wouldn't see Ryder, right? I wouldn't see anybody on this row, because all I would see is directly in front of me, or if I was facing this way, directly behind me. There would be no height to things. You see what I mean? No depth. And so depth and height create a 3 dimensions. When we're doing the XY axis, we're only dealing with 2 dimensions. This board is all that exists. There is no up, there is no chair, there is no desk. Think about it just being the flat floor. Everybody with me on that? So we have to give directions based upon a flat floor or a flat idea. This idea is like a map, if you think about a map. A map represents 3 dimensions, but it really is only in 2 dimensions. It's only on a flat surface. What is this axis then? This is the x-axis. The x-axis goes across, okay? It goes across the values, and it creates a system where you can have an x and a y that creates the up and down. So the y goes, if you want to think about it, north and south, but really it's up and down, and the x-axis goes right and left. Now when we create a point, what does the 3 represent? A value on the x-axis. The 2 represents a value on the what? Y. Here's where I see kids mess this up though. Is that 3 too? No. It has length and width. It isn't just one single line where there's a 3 on one line and a 2 on another line. No, this is actually going over 3 and up 2. I should go over 3 first for sure, okay, because the x comes first. So you always go right and left first, and then you go up and what? Down. Now that's going to get confusing when we start doing lines, because we're going to go like up and down first, and then left and right. But you'll see why when we do that. Okay, so that's pretty easy. Is there any question on points? I think you're pretty good on this. This is what you should have already learned. Any questions on how to mark a point on a graph? Anything like that? Everybody understands you mark the X and then the Y. You don't mark just the axes, you actually travel across and then up. Everybody with me so far? So that's 0.32. Okay. Now, here is the tricky question. Okay. When I'm on the y-axis, so you got to think here for a second. When I'm on the y-axis, what is the value of x? The points. What are the values of the x points on the y-axis? What did you say, Logan? 0. Everywhere along this y-axis, so if I actually mark, say, this point, okay, what's that point right there? How many down have I gone?
5.
So is this point negative 5, 0? No, it's actually what? 0, because the x should come first, and negative what? 5. Everybody agree with that? Okay. So when I'm on the x-axis, what's the value of y? 0. When I'm on the x-axis, the y value will be 0. So what is this point right here? I'm over 1, 2, 3, 4, 5, 6, 7. Griffin, what's this point right here then?
7.
7 what? Is it just 7? No, every point, and this is an important thing to understand, every point on this plane, on this Cartesian plane, has to have coordinates. It has to tell us where they are. So we have to have an x coordinate telling us I'm going to go over to the right, what? 7, and then I got to have a y coordinate. The y coordinate, though, hasn't moved, has it? So it's going to be 7 what? 0. You have to have coordinates. Has anybody ever done geocaching? What is it, Addie?
Geocache. So if you can get this app or something and you go around, like, mainly in the desert areas, you can find little prize things, I guess, little things that people put there.
Yeah. So you actually take a GPS coordinate. What is a GPS coordinate then? It has an XY axis. It actually takes the curvature of the Earth too into account, and it gives you a location based upon latitude and longitude, and you end up going to that location and you'll find a little something. You can go out to Victor, and there's a geocache thing out to Victor, kind of by the cemetery, and it's right by the, oh, you guys don't know where Victor is, do you?
There's some out in San Rafael.
Okay, so there's a whole bunch. They're all over the place, actually. And what you're supposed to do is like take something out of there and then put something back in it so that somebody else can get something else later. But it's kind of fun. Gives you something to do, and it's kind of an interesting thing to get you out and seeing some of the country out around where we live, and it's kind of cool. So, but everything that they do has a coordinate, has an x and a y, or a latitude and a longitude, right? You have to have coordinates. You can't just say 7. 7 doesn't tell me anything, right? I have to have a 7 and a what? 0 or whatever. I have to have 2 values, both an x and a y. All right, well, that tells us a lot right there. Now we're going to start connecting a line, okay? So let me give you the general, and this is called the standard form of line. This needs to go in your notes, so take out some notes here. This is the standard form of a linear equation. Notice that there are how many variables in the equation? Okay, well actually, in this equation, there are only 2 variables. There's an x and a what? Y. The a, the b, and the c are variables in the equation right now, but the a, the b, and the c are going to represent what when we have a normal written equation? Yeah, the a, the b, and the c are going to represent numbers. So the a, the b, and the c are all going to be numbers in this equation, but the x and the y will never be numbers. The x and the y represent what? The x-axis and the y-axis on the graph. So therefore, the x and the y are variables, meaning they vary depending on where you're at on the x and y coordinates, but they are what's changeable. Your a, b, and c values won't be changeable. They'll be a number value, okay? Let me give you a real easy example here. Let's say I had 2x plus 5y equals 20. And I wanted to graph this equation. Okay? Now, if I want to graph this equation, all I got to do, how many points do you need to graph a line? You only really need 2, okay? Now, you can have more than 2 that are on the line, right? But any 2 points create a line. Okay, Danny, stand up. Show Danny. Okay, so Danny's over there, and I'm over here. How many lines, now show me. How many lines can I draw between Danny and I? Can I draw another one that goes out around like this?
Sure.
And one that goes around like this? And then one that goes straight from me to Danny? Are all those lines?
Yeah.
No.
Have to be a straight line.
Ah! All lines are straight, okay? There's only one line that will connect Danny and I. Now there's curves that we could do, right? We could curve out around and create connection. But truly there's only one direct line between Danny and I. Is there any, obviously again, we're talking 2 dimensions, just on the floor. There's only one way we can get there. Okay, go ahead. So every single point, there's only going to be one line. For example, if we were to connect Callie and Addie, from here to Addie, how many ways can I get there? If I'm going to create a line. There's only one way. I would have to go straight through there to create a line. So if I have 2 points, I can connect a line. Now, remember that in this case, the x represents x coordinates and the y represents y coordinates. The easiest points to find in standard form where the coefficients, now I'm going to say another word you might want to note and write in your notes. Coefficients. What does coefficient mean? Write this in your notes then, because if you don't know it, you need to write it in your notes. What does the word coefficient mean? Anybody know? The number in front of a variable. That's the coefficient. The coefficient for the x then is what? The coefficient for the y is 5. 20 is not a coefficient, it's a constant. How come? It's not in front of a variable. Everybody got that? So this is called a constant. A constant is a number without a variable. You might want to write that in your notes. A constant is a number without a variable. And a coefficient is a number being multiplied to a variable.
What, a constant in a what?
A constant is a number not multiplied or connected to a variable. A coefficient is a number value multiplied and connected to a variable. Okay? So we have coefficients, we have constants. The easiest way, especially if these 2 coefficients are factors of that constant, the easiest way is to find the x and y intercept. How will I find the x-intercept? How will I find where it crosses the x-axis? What should the value of y be? Canyon. If I'm on the x-axis, don't worry about the equation right now, just think about being on the x-axis. What is the value of y? Any point you pick on this x-axis, what's the y value?
0.
0. So for this line, this is an equation of a line. If I pick the y value being 0, and then solve for x, oops, sorry, put an x1 in there. Okay, and solve for x, what will the value, where will I be on the graph? I will be where y is 0, and x is wherever it's going to be on the x what? Axis. So if I, and this is what you want to put in your notes. Let y be 0 to find the x-intercept. Let x be 0 to be the what? To find the what? Y-intercept. I'm going to create 2 intercepts, and then all of a sudden I'll be able to graph a line because I'll have 2 points. Okay, so let's do this one first. So if I let y be 0, look how easy this is. What's 5 times 0? What's anything times 0?
0.
That goes away basically, and I'm left with 2x equals 20. Divide by 2, what's x? That's all I got to do is mark 10 on the what axis? X axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we are. This point is what? 10 what? 0 because I put in 0 for y, 10 because that's what I solved for x. What should I put in for x if I want to find where it's going to cross the y-axis? 0 for x. Again, 0 is the coordinate for this value. So 2 times 0 plus 5y equals 20. Again, that's going to go away really easy. I'm going to divide by what? 5. Leave the y on one side by itself. Just divide by 5. Don't divide by the y. 20 divided by 5 is? 4. Where should I mark that?
4.
Up or down? Up. So remember, positive y's are up here, and you might want to put this on a graph. If you didn't already know it, most of you know it. And positive x's are over here. Negative x's are over here. Negative y's are down here. Okay? So I'm going to say it's going to be at a positive 4 on the y. Okay, now I have a 4 and I have a 10. And this is 0, 4, by the way. Because I have 0 for x, 4 for y. Can I connect those 2 points?
Yes.
Yeah, if I have a ruler or the side of a calculator or something, it's really easy to connect these. And boom, I have it. Very simple. Okay. Now, there's a problem. This is great. Okay. It works great when what? When these are factors of this. It doesn't work quite as great when it's not. So let me give you an example of that. So let's say I had 2x plus 3y equals 11. Let's try and graph this one. And there's a reason this doesn't work quite as well. Now it'll still work. But yeah, you're going to have either decimals or fractions or something like that. Let's make this one negative just to make it different. Okay? All right. The process though is exactly what? The same. So writer, if I want to know where it's going to cross the y-axis, what should I sub in for x? Again, think about the axis. On the y-axis, what's the value of x? No matter where I'm at on that y-axis.
0.
0. So I want to substitute in what for x? 0. Let's just put in 0. I'm going to find where it crosses the y-axis. What's 2 times 0?
0.
That's 0. Minus 3y is negative 3y. Gannon, what should I do next to get the y by itself?
Divide.
Divide by what?
Divide.
Not just the 3, but the what?
Y.
Not the y. Leave the y by its what? Self. I got to divide by the what besides the 3, though?
1.
The negative. The negative in front of that 3, okay? I've got to divide by the negative in front of the 3. I need the y to be positive because I'm solving for the value of y. Y equals what? Negative 11 thirds. What the heck is that? That's actually a point. It's just that it's a fractional point. If you think about it, how many times will 3 go into 11? 3 times with how many left over?
3.
2 left over. Yeah, I was going to say it can't go in 3 times with 3 left over. But 3 times with 2 left over, it can. So think about that. 3 times 3 is 9. 9 plus 2 more would be what? 11. So this is actually negative 3 and 2 thirds. Okay, that's nice. Where in the heck is that? Where's negative 3 and 2 thirds?
Right after, right before.
So I'm going to go negative 1, 2, 3. Is it before negative 3 or is it after negative 3? It's actually after negative 3. So I got to go 1, 2, 3, and 2 thirds. And then I'm guessing. Can you see that on the graph? And then I'm like, okay, that's about 3 and 2 thirds. It's not maybe perfect, but it's close. And that's the problem with when they're not a factor, obviously. Okay, how do I find the x value, Briley? If I want to find where it crosses the x-axis, how will I find that? Is it Brayley?
Yeah,
Sorry.
it's okay.
So how do I find where it crosses the x-axis?
So it's just the y 0.
I'm going to make the y 0. So 2x minus 3 times 0 equals 11. Again, 3 times 0 is 0. That kind of zeroes out, goes away. Again, now I have 2x equals 11. How do I get the x by itself, Tristan?
You gotta divide
By what?
2.
By 2. I want to get rid of whatever's in front of the x by dividing it out. X will be, again, I get a weird little 11 half. What the heck does 11 halves mean? Again, you gotta divide 2 into 11. How many times will it go? 5. And how many will be left over? 5 and a half then. So I'm gonna say, okay, this is 5 and a half. Where in the heck is 5 and a half? Well, that's a little easier to find than like 3 2/3, but still, 5 and a half is about there. Now I got this graph going through. It still is easy to connect if you have a calculator, but it's not as precise because I don't know exactly where 2/3 is. I mean, I guessed pretty good, and it's not a bad guess, and you can still do it, but it's tougher with fractions and decimals. Did everybody see that? And so we're going to learn a different way to graph later, but for today, we're just going to graph 2 points by subbing in what for x to find the y, 0 for x to find where it crosses the y-axis, what for y to find where it crosses the x-axis. 0 for y will find the x-axis. You can shut that off.